often don't need all the data we have available. We may not need all the features, for example, for our modeling efforts. We also may have so much data that we don't need to use it all. We may want to use just a part of the data. So let's see how we can use some of the RapidMiner operators to help us in those situations. All right, so here we'll start with the bike buyers data. So we've seen that data set a few times. And if I bring that in and we just look at it, we can recall, okay, we've got numeric and categorical versions of many of our features. If I know, for example, that I want to do a regression, well, then I probably don't want those categorical features. I just want the numeric versions of them. So in this case, I can bring up a tool called Select Attributes. And that is under the blending folder. So select attributes. And in this case, it gives me the option of determining, well, do I want to include certain attributes? Do I want to exclude certain attributes? I can then also choose all attributes, one or subset, types of values. So here I could say, just give me the numeric ones. So I've got a lot of different options. As a matter of fact, real and integer would be a good approach to use here. So if I were to run that through, and we'll call this data prep sample. This is just one aspect of data prep, but we can call it that. This goes in models. All right, so you can see now I only have integer features remaining. Okay. All of my fields are numeric, whereas the input, I had a variety. Now I could flip that. So instead of real and integer, I could say, well, let's just keep the binominal and non-binominal nominal. And I could keep text fields. I don't think I have any in this particular one. Date and time fields. All right, so if I run this now, you can see now I have marital status, gender, education, occupation, commute distance, region, purchased bike. Now, it's very rare that I'm only going to want to keep nominal features. So in this case, instead of saying type of value, I would say, let's get a subset. And now I could select which ones I want. So age, yeah, I'll keep that. Number of cars, number of children. And then I'll keep the categorical versions of all of these where I have both a categorical and a numeric version. Income I'll keep. Marital status, occupation, purchased bike, and region. All right, so I can apply that. And now I've got a good mix of attributes, both nominal and numeric, that I can use for my classification modeling efforts going forward. So classification, generally I have the flexibility to use both numeric and nominal attributes, whereas when I'm trying to do some kind of a regression, I'm going to need numeric feature attributes. All right. And if I'm regressing to a real number label value, then of course I need a numeric label value as well. All right, let's see what we can do next. We've selected attributes. Now there may be some points in time where I don't want all the data I have available. Now, bike buyers was a relatively small data set, 1,000 examples. Let's go find one that's a little bit bigger. So here I've got some lending club data files. I've got a large one and a small one. Let's take a look at the large one and just take a look at the statistics. Okay, so loan status. I've got 167,000 examples in here, 35 different attributes. So yeah, this is one where I may not want all of those. So let's say I'm going to bring this one in. And instead of grabbing all the data, I just want to sample the data. So I'm going to bring in the sample operator. And you can see I've got a number of different options here. I'll just bring in the basic sample one. And I've got a couple options here. I could say, give me a sample with an absolute count. So in this case, it would give me a sample of 100 examples. I could also use relative. So the ratio. So in this case, it would give me 10%. So let's go back and say I want an absolute sample of 20,000 examples. All right, yeah, that's 20,000. Now I could also put a random seed in. If I don't, it's going to give me a different sample every time. If I do, I can make this so that it will give me the exact same sample every time. So in my case, I can put in a random seed, 1, 2, 3, 4, 5, 6. And now, if I get that sample, remember I had 167,000. I will now run this, and you can see my example set coming out of the sample operator now has 20,000 examples in it. And I've got the stats for them that hopefully are fairly similar to what I had before, but probably have some differences. Okay, so that's an easy one, sampling. Now I could, let's go back just to say, if I were to go back and say, let's do a relative sample of 0.1. Well, I know I had 167,000 some odd examples, so that means I should end up having 16,000 or so when I run this one. And yeah, 16,760 examples. All right, so that one's pretty straightforward. Another one I can use is split, and it's right here in this same subfolder, so I'll go ahead and pop that in here. Split allows me to create as many splits of the data as I want. Generally, for the purposes of what we'll be doing in our modeling efforts, we would create 2. And I can have it sample a number of different ways, stratified being one that's commonly used by accountants for audit purposes. Again, I could set up my random seed to make sure I get the same results every time. If I don't, of course, I'll get a different split, a different set of samples each time I run this. It generally picks up the random seed from the computer clock or some kind of a process that the underlying programming language that this was built on feeds to RapidMiner. All right. Next, I can go here and say, okay, let's say I'm going to use ratio, and I'm going to say I'm going to create one split with 40% of the data, 0.4. I'll create another split with 0.35 and another split with 0.25 of the data. All right. So the idea here is I hope that adds up to 1, and I click OK. And watch this operator here. As I connect each partition to the wall, another one pops up. Now, I only created 3 partitions, so those would be the only 3 that are going to give me anything. Just for kicks, we can add this one and see what happens. As a matter of fact, it won't do anything because there is nothing to send out. I guess a visual indicator that lets us know that is these partitions are dark, which says there's going to be something in them. And then when I've use all three that I have, my next partition output port is blank. All right, so let's go ahead and run this. And you'll see I get a split here, one with 58,000 examples, another one with 67,000 examples, and then this third one with 41,000. Those are my three splits. Now, in general, we're going to do something for our purposes of just creating two splits, one for building our model and one for testing or validating the model. So my first split might have 0.7, 0.75, 0.8 in it. 0.7 to 0.8 is generally a good percentage to build your model with 0.2 to 0.3 reserved for validating your model. So I'll just split the difference here and go 0.7525. Click OK. And now, of course, I don't really have anything to add in that third one. Yeah, I still just have 3. And because I had it filled in earlier, I guess I forgot to not use it. Let's see if I delete this. Yeah, now it knows there's nothing there. So it didn't change the visual until I got rid of all my partition connections to the results wall. So now if I run this, I'm going to have one split with most of the data. That's this one here with 125,705 examples. And then another split with just a little bit of the data, 41,902. All right. So that is splitting the data. And then we also did sampling. The last thing we might want to do, and we'll go back to the smaller Lending Club data for this, is remove duplicates. Sometimes your data may have duplicate data in it that you were not expecting, so it's important that you get rid of them. And that can be for a couple reasons. The duplicates were put in there by mistake. Duplicate information can, is kind of a waste of processor time unless you have actually different results coming from those duplicates. In that case, that might be interesting. But if we have duplicates all the way across, that could affect the model results that we come up with. So let's do this with the Lending Club, and I'll find duplicates here if I can. Remove duplicates. There it is. And here I can set it up to remove, in this case by default, only if all the features are exactly the same. But here I could set it up to remove duplicates also if any subset that I select of my attributes are the same. So this might be a good one to use if you're trying to clean up, for example, a vendor file. Over the years, a single company may have added a vendor multiple times because maybe one of the users didn't know that vendor was already in there. So lots of different reasons to remove duplicates. Let's go ahead and see what we get. So first off, we've got 3 output ports. The first one is going to be, well, here is my data after I have removed the duplicates. I can also list the duplicates that were removed. So that's what that duplicate one. The second one is, here's my original data. So I can take a look at that. All right, so I'm going to go back to remove duplicates. We will say all. I'll remove the duplicates only if all the fields are exactly the same left to right. So I click go. And I look at my results. So here's my original data, 10,492 examples. So here's where here is the one that shows the duplicates I did remove. And I removed one row of data here that duplicated another row that was in there. So that leaves me with 10,491 examples that I can then continue with. All right, so we've had a chance to select just the attributes we want, whether they be all numeric or a mix of categorical and numeric. We've talked about data leaks, so that would be another reason to pull some attributes out of your modeling efforts. Okay, we've sampled the data or down sampled the data using the sampling operator with the large lending club data. We also used the split data to create multiple partitions out of the data. And then we finally took a look at the remove duplicates to remove any kind of repeating information that we may have in our data set that we don't want. So that's it for this video. Let's get back to our reading and see what we'd like to do next.